Now let's see how aspirin works. Whenever there is an inflammation or an injury or anything that is causing pain at a source, these cells start to produce a chemical that will then produce prostaglandins. Prostaglandins are involved in the transmission of pain impulses to the brain, and it also causes fever and swelling. Now, what does my analgesics do? Like aspirin, they block the action of enzymes that produce the prostaglandins. So if there is an inflammation or an injury at a site, let's say these are cells that are damaged, so there's going to be chemicals released. These chemicals will act on an enzyme, and this enzyme will produce prostaglandins. These prostaglandins will then fit in receptors of nerve cells that will carry the message to the brain, and then you start feeling pain. So what does aspirin does? It's going to block the production of prostaglandins. So if there is less prostaglandins, or if its production is completely blocked, there is no transmission of pain to the brain. And hence, pain is reduced or eliminated. In addition to relieving pain and reducing fever, aspirin also reduces inflammation. Aspirin is also used as an anticoagulant, and this means that it prevents the blood from clotting and hence reduces risks of heart attacks and strokes. And because of its anti-inflammatory properties, aspirin is also taken in arthritis and rheumatism. Arthritis is a condition where there is acute inflammation of joints, and this causes pain. So aspirin has anti-inflammatory properties and can be taken as a way to reduce pain from arthritis. However, aspirin also has side effects. Side effects of aspirin include bleeding of the lining of the stomach, decrease of pH of the blood caused by salicylic acid, and Reye syndrome in young children. Now, aspirin on its own will cause the bleeding of the lining of the stomach. However, when aspirin is taken together with alcohol, it's going to accentuate this effect. This is called a synergistic effect. Two drugs can have synergistic effect if they increase each other's effectiveness when taken together. In this case, alcohol will increase aspirin's ability to cause bleeding of the stomach lining. Now, in order to avoid the side effects of aspirin, especially in children, we can use alternatives such as paracetamol and ibuprofen. You have the structures of paracetamol here and ibuprofen here. These are alternatives to aspirin. And especially in young children, we prefer to give paracetamol instead of aspirin because they have less pronounced side effects. However, we have to be very careful with the dosage of paracetamol because it has a relatively narrow therapeutic window, and high doses can cause permanent damage to the brain, liver, and kidneys. And similar to aspirin, ibuprofen increases the risk of stomach bleeding when taken with alcohol. So this is very important that any drug should not be taken together with alcohol. Now, aspirin is a largely non-polar molecule, and because it's non-polar, it has low solubility in water, and this reduces its bioavailability. Remember that for a drug to be bioavailable, it needs to have both polar and non-polar groups. So the polar groups will allow it to be soluble in the blood, and the non-polar group will allow it to cross the cell membrane. So the bioavailability of any drug which contains an acidic or basic group can be increased by converting them into ionic salts. So this part of aspirin is an acidic group, and this can be converted to the salt form so that it becomes more soluble. So in this case, it can be reacted with NaOH, and it's going to give you the salt, and this one is more soluble than the original form of aspirin. However, the problem with this form of aspirin is that once it goes into the stomach, it's going to be converted back to aspirin. So when this is reacted with acid in the stomach, this is going to form back the aspirin as it was, which means that the bioavailability of soluble aspirin is only slightly higher than that of plain aspirin. So it doesn't make a lot of difference.